This is another equation practice video, and this one is going to be a combination of the two equations Q equals IT and E equals QV. And if you substitute the Q, so if you put IT into there, you end up with energy is equal to ITV. Easy one to remember. ITV is obviously channel 3. So forgive my not quite rectangle. E is energy, joules. I is current in amps. T is time in seconds. And V is voltage in volts. So you want to make sure you've got that information down, and then we can work through these questions. So I'm going to remove all that. If you want to pause, I want you to do question 1 and 2, and then I'll take you through the answers. Alright, let's have a look. So first one, a device has a current of 10 amps flowing through it. The voltage across the device is 50 volts. If the device is left on for 1 hour, calculate the energy transferred. So really straightforward. Energy equals ITV. So current is 10. The time, 1 hour. So there's 60 seconds in a minute and 60 minutes in an hour. And that gives us 6 times 6 is 36 and 2 noughts seconds. So we've got current of 10 times time, 3,600, times voltage of 50 volts, and that will give us the energy transferred, which is 1,800,000. So 1,8 and 5 zeros. You could write your answer as 1.8 megajoules if you wanted to, or even 1.8 times 10 to the power of 6 joules. All the same thing. All right, let's look at the second one. An electric heater is left on for 489 seconds with a potential difference of 5.3 volts and uses 22,800 joules of energy. So this time we're going to calculate the current. So energy is ITV. And to rearrange this one, it's pretty straightforward. So what do we need? Calculate the current. So we're making I the subject, so we've got a times T and a times V that we need to get rid of. So we just need to do the opposite of timesing by TV. And the opposite of timesing by TV is dividing on the other side, like that. And that'll give you your current. So energy is 22,800 divided by time times voltage. So 489 times 5.3. If you put that in your calculator, you'll get the answer, which is, to two significant figures, 8.8 amps. All right, let's try number 3. So if you want to pause and have a go at this one. All right, I'll take you through it then. An electric current is an electric device is left on with a potential difference of 7.5 volts, current of 4.98 amps passing through it. And the time it is on, it uses 500 kilojoules of energy. Calculate how long, so we want time. So same equation, E equals ITV. And then we just need to rearrange to get time. So we've got, to make T the subject, we need to get rid of a times I and a times V. So what's the opposite of timesing by IV? Is simply dividing by IV on the other side. So the energy is 500 kilojoules. Remember that kilo means 1,000, so that's 500,000 divided by current times voltage. So the current is 4.98 times the voltage is 7.5. Calculate that. That gives us a time of 13,387 seconds, or something like that would be fine. All right, let's do some more. So a little bit trickier. So if you want to pause and do 4 and 5, and I'll take you through the answers. So on 4, food blender is left on for 50 seconds. It's got a current of 7.8 amps, and it transfers 89.7 kilojoules of energy. Calculate the potential difference, or the voltage. So E equals ITV. And to get voltage on its own, we need to get rid of IT that's multiplied. So the opposite of timesing by IT is dividing by IT. So let's put some numbers in. So energy is 89.7. So you need to multiply that by 1,000 because kilo means 1,000. which is 89,700, divided by IT. So current is 7.8 times time, 50 seconds. And if you calculate that, that gives you a voltage of 230 volts. And that should be ringing a bell, that number. If not, it might do shortly. All right, let's look at number 5 then. So this one, a device plugged into the mains, transfers 100 megajoules of energy in 10 hours. Calculate the rate of flow of electric charge. Right, first of all, the rate of flow of electric charge is electric current, because current is charge over time, and rate of flow means divide by time. So what we're actually finding is the currents. Well done if you spotted that. Okay, so E equals ITV. And we want I, so we want current. So we need to get rid of the times TV. So the opposite of times in TV is divided by TV to give us the current. So the energy is 100 megajoules, so that's 100 million, so 6 noughts, or times 10 to the power 6. Divided by time, so we've got 10 hours. So let's do this here, 10 hours. So 10 hours is, you've got 10 hours multiplied by 60 minutes, multiplied by 60 seconds. So it's 3,600 times 10, which is 36,000 seconds. So pop that one in there. Times the voltage. Now it's plugged into mains, and you should know that mains voltage is 230 volts average, which is why I said that should be ringing a bell. So times that by 230. And that gives a current, or a rate of flow of electric charge, of 12.1 amps. And just a bit more information, the maximum current that you could possibly have for mains electricity is 13 amps. Right, anyway, I hope that helped. Thanks for watching, and I'll speak to you soon.